Alrighty, well, welcome. My name's Noel Gorelick. I'm one of the founders of Earth Engine, and I'm going to basically spend an hour apologizing for parts of the system that I built 15 years ago. But more to the point, it's how to get the most out of Earth Engine, working around all of the weirdness that we built in. This is an amazing crowd. This is the most people I've ever had in this session. Thank you. We'll see how that works out in a minute. OK, so I'm going to talk about how to do basic debugging so that you can fix your scripts and I don't have to. My regular weekday starts on Monday with a couple emails that contain 3,000-line scripts from scientists going, hey, what's wrong with my script? And I spend the week fixing those problems for those people. Don't send me your scripts, please. But most of them are things that you could fix yourself if you just knew what to look for. And so this is a talk about what to look for. For me, God, people are just still coming in. This is amazing. For me, debugging and scaling in Earth Engine are basically the same thing. If you hit a scaling limit, then you're going to have to debug your code to find what you've done that is causing you to hit that scaling limit, fix it, and move on. So they look the same to me. I'm going to talk about common errors. So if you already use Earth Engine a lot, you will have hit a bunch of these errors and probably worked through them. But more about how to recognize the errors and what to do with them. A little bit on our performance tools. Item 2.1 in here is actually a thing I developed last year, which is when I'm looking at your script and you've got a scaling issue or whatever the error is, there's about 50 things that I look for. And it's just sort of an ordered list of, if you're doing this, if you're doing item number 1, you've got a problem, fix that first. And we just work our way through these 50 items. So I figured if I give you that list, we can short circuit all that, and you can just go straight to the working script from where we are. And then a little bit at the end about how to get help. Again, if you're already an Earth Engine user, maybe you know how to do this, but it doesn't hurt to tell the new people. All right, so basic debugging. I'm going to assume you're using the code editor. If you're not, if you're using Python, you've got a whole different set of problems. But we'll talk about what the code editor can help you do in terms of debugging. The code editor understands JavaScript. And as you're perhaps aware, you write most of your Earth Engine code in JavaScript. And if you make bad JavaScript, if you just put three random words into the code editor, it's going to say, I don't know what that is. And if you put a bunch of other random characters in there, it's still going to say, I don't know what that is. So it's really hard to figure out what bad JavaScript really means. It knows what good JavaScript looks like. And if you give it good JavaScript, you're good. But if you don't, you'll get these little X's on the side of the code editor that says, something's wrong here. They're not super useful as a diagnostic tool. It just says, there's something wrong here. You need to look at this line or the line above it or something, because the JavaScript stopped working at this point. We were unable to parse it any further. And so in this case, there's an unclosed string. I've got an extra quote in there, actually, is what it means. So that message may or may not be super helpful. Just know that the X's kind of sort of show you where things start going bad, and that's where you should start looking. So those are syntax errors, things that the code editor can tell you before you even click run, but before anything happens. It's just, this couldn't ever possibly run. And then there's code that is syntactically correct. It's JavaScript that's legal, but it may still not work. And so this is things like typos, variables misnamed. Here's an example of trying to use a variable that doesn't exist. And when those occur, we tell you what we can. But these are, again, a little easier to detect, because as we're running it, we get to a point and the JavaScript parser goes, I don't know what's going on here. And so we can tell you, oh, line 3, something bad happened, maybe with a good error message. And then there's the hard ones. And all the rest of this is about the hard ones. Sometimes you have perfectly good JavaScript. It actually runs and compiles and sends the thing off to the server. And the server goes, I don't know. And so here's an example of trying to use a image collection where the band names are wrong. And until we get an image in hand and can actually look at it, we don't know if those names are wrong. But when we do, it's way too late to tell you where that happened in your script. Your script has been basically compiled. All the duplicate pieces have been removed. A big giant, what we call computational description gets sent off to the server. Server starts parsing that and says, problem. And so if you have server-side errors, it is often the case that you have very little indication where in your script that went bad. But we try to tell you what we can. And so in this example, I am, what am I doing here? I'm running a median reducer over something. And the median reducer tries to go get a red band, and it can't. And so it tells you the image it was working on at the point where that failed. And sometimes that's enough to help you figure out what's going on. If you had like a inhomogeneous collection, some of the images have these names, some don't. It tells you what it was working on when things stopped working. And sometimes that's the best you can get to start doing your debugging with. All right, so we're going to talk almost entirely about server errors for the rest of today. Who's seen this talk before? All right, you're going to get the same jokes. I'm sorry. That's just the way it's going to go. We have an assortment of debugging tools that are fresh from the 1970s. They are essentially print statements, right? That's if you've already written some Earth Engine code, you're probably aware of this. Because this is client-server code, you do some stuff on the client, you build a computational description, you send it off to the server. It's incredibly difficult to give you meaningful introspection code. So you often are responsible for saying, stop here, tell me what's going on. And print is the way to do that. The way I write code, I'm a software engineer, I've been doing this for years, and the way I write code is after like 10 lines of code, I've kind of forgotten what I'm doing and I want to print, or I want to stick something on the map, and I want to make sure I'm doing it right. This is the equivalent of unit testing, but I don't actually want to write a test. It's just, here's 10 lines of code. Am I getting the thing I expect, yes or no? And it should be just a few seconds to say, yes, I got an image. I didn't misspell my band names, whatever. So as I'm writing code, 10 lines, print something. OK, take my print out. 10 lines more, print something. Take my thing out. If I'm working on maps and actual computational numbers, I'll stick it on the map. Stick the layer on the map, inspect something. Yes, that's a value that is not absurd. It may not be right, but at least the pieces all mesh and the gears turn, and I've got something I can then work with. As I just said, the inspector is the tool for doing most of that. When you're doing quantitative analysis of your results, quantitative debugging, quantitative testing, you just throw it on the map, inspect it, look at the results, and say yes or no. When you get deeper into your code and you're doing something like we showed just a second ago here with the median, something happened. This is the image that went bad. Reducing everything down to just that image is often the best way to figure out what's going wrong. So if you've got a collection, you can filter it down to just that image ID. You've still got a collection, but it's got one element in it. And so any other massive amount of computation you've got going on, you sort of take out of the equation. And now you've got one image and you can see. You can also, if you want 3 or 4 images, because it's one image is not enough to do like correlation. You need 2 images. Limit your collection down to just a little bit of data that includes the problem data. And then sometimes you don't really want to keep working on the collection. Maybe if you're mapping a function over a collection, for instance, you can't print inside of it. There's a whole bunch of stuff you can't do because it all happens on the server. Yeah? And a way to get around that is stop mapping, take your function, and just apply it to one image. So for instance, you're computing NDVI for a whole bunch of images with a function. Take that function, apply it to one image, and now, because you're not mapping, print works, map add layer works. You've got the ability to inspect one of those occurrences. And hopefully, the error that you got a minute ago, where you've got an ID to work with, you can work on that particular image and see what's going on. So reduce the problem down to the smallest unit that still fails and start debugging that, rather than waiting an hour for your million images to process to get to, oh, I misspelled the band name. To make all this a little bit easier, we added a function a long, long time ago called aside. And most people don't know about this, don't use it. What aside does is it allows you to keep the structure of your code. hopefully you're aware that Earth Engine code is designed to do method chaining, where you get a collection, do something to it, do something to that result, do something to that result. You chain together a bunch of methods. But if you want to print this thing in the middle, normally what you have to do, or more importantly, when I'm trying to debug your code, what I have to do is change your code. I'll have to put that into a variable and print the variable, or wrap a print statement around part of that. But I will end up fundamentally changing the structure of your code so much that I might actually unbreak your code, right? I want your code to stay broken so I can see what is causing the break. And if I try to disassemble this into something I can print pieces of, that can cause a problem. So the aside function, it's actually like dot aside, is a thing that's on every Earth Engine object. And you can stick that right in the middle of your code. So I could actually just drop an aside print right here. And what it will do is it will take the object that you've got, call the function on it, print, and return the object. So it's essentially a no-op operator that will also run that function. So we could aside print here and here and here and here, and quickly add debugging tools, quickly see what's going on, but never have to actually fundamentally restructure the code. So it's super valuable. As an aside to the aside, anything that you put after the function becomes arguments to whatever that is. So you can actually do a map add layer here and then add visualization parameters. And whatever you're assiding on will then end up on the map with whatever those visualization parameters are. You don't need to make a new function. You can use the built-in functions and then just pass extra arguments as part of aside. OK? Good news is, not so hard. Bad news is, that's kind of the limit. We don't have more detailed inspection tools. That's the basis for debugging. It was good enough for Fortran in the 60s. It should be good enough now, right? No. But sorry, that's what we got. All right, so an example of doing this kind of thing. We have a function. It's going to compute, or it's going to run a reduce region on an NDVI image. It's going to get the result out. It's going to do something to another image based on that result, return it, and map this. And so when you're running this and something doesn't work, it says ID 16434 broke. It tries to tell you what was running when it broke. So the where function didn't work as expected. And it says parameter test is required. Nowhere in this did I use the word test. But you should know all the arguments inside of Earth Engine functions have names, because you can call them by name. And the where function has two arguments in it, a test and a conditional. The test failed. Essentially, what this means is you passed nothing into the where function as the map was running. What it really means is somewhere along the way, there was a null NDVI value. You didn't do any null checking, anything like that. And you ended up calling where with a null value, null test, and it broke. I actually need to see what the rest of my thing is. OK, so testing this out, you take the collection, you filter down to that one problem item. Make sure it still fails by mapping that function over that one item collection. Yeah, it'll probably still fail because that was the problem. And to be able to start printing things and debugging them, you can do the same filtering. You take the first element, the only element in the collection at that point, manually call your function on that element, and now you're in a point where print and map add layer and all those other tools start to be useful again. OK? So this is a tiny bit of restructuring on your code to figure out what went wrong, and that's the best way to go about it. OK? I saw a little nodding. You can nod. I like nodding. No, no's are good too, just something. OK. Common errors. The good news and bad news about knowing most of our users for the first 10 years of Earth Engine's life was that I kind of saw everything they did. And this is a collection of kind of everything that everybody hits. So there are different kinds of common types of errors. Things we call early errors. We've talked about those a little bit. Things that happen in map functions. Talked about that. A whole set of things you shouldn't do. And some things to help you with your scaling. So here's an example. For anybody who has not seen this talk before, what's wrong with this line of code? I'll take a hand. Earth Engine engineers, cut it out. Anybody? Yeah, in the back. Correct. The thing happens, and the results go nowhere because we didn't assign it into a variable. Earth Engine is a lazy system. If you don't do something with the result, it's never computed. So essentially, this line never happened. Anybody else? There's more here. Yeah. Close, yeah. So the intent is correct. The semantics a little wrong. You're dividing something by a number. The intent is probably, whoever wrote this code, I wrote this code, whoever wrote this tried to get a time out of an image, which is actually a long number. It's in microseconds. And they're trying to convert into days, I think is what that's trying to do. But whatever comes out of get is a computed object. It's a lazy operation that happens on the server sometime in the future. All Earth Engine operations, anything that involves an EE dot something or a result of an EE dot something, is a result that happens in the future. Okay? This slash, see if my pointer works here. Nope, it does not. It works, you just can't see it. The slash is an operation that happens in the browser right now. As soon as you click run, the JavaScript is interpreted, the dividing tries to happen. You're trying to divide a computed object by a constant, and that doesn't work because there is no computed object. It will happen in the future. You're trying to divide something now. It breaks. What else? Well, I guess you kind of said. You said two things there. The thing that comes out of the image, when you get something out of any other object, the system doesn't know what you have until that object is evaluatable. Until the system has an image and has the result, it doesn't know what you've got. It could be an image, it could be a time, it could be a string, it could be a collection of collections of dictionaries of something, something, something. And so maybe it's not even a thing which division is even possible on, right? So frequently, as you get objects out of other objects, you need to tell us what that is so that you can then actually do something with that object. And I'll show you in a second what that means. So first problem, result capture. Great job. Second problem, JavaScript operators. If we changed this to be image.get something, something, something plus this big long number, what you actually get is the computed object's representation, the wire format that Earth Engine actually used, turned into a string. Just what JavaScript does. You're going to add something to a string, it'll be happy to do that. Going to add something to anything else, it'll turn it into a string first, some big, long, ugly string, and then it will tack on the other object on the end of it. And so this bit of math turns into 86 million, and it sticks it on the end. So if you ever are printing objects and you see a whole bunch of weird JSON, what that means is one of your computed objects, one of the proxy objects, gets converted into a string. You've done some math with it somewhere. Bad on you. Don't do that. All right, so the way to fix this, capture the result into some other variable, maybe the original variable. Sometimes you got to do casting. Maybe you can just wrap the result with the casting type so that you know, or you've printed, or you just automatically know that the result's going to be a number. So you can just say, hey, this is a number. And that will give you access to the divide function, right? There is no divide function on a string or a list. It only occurs on numbers and images and those sorts of things. So the casting tells the client, this is going to be a number. When I call divide, I mean number.divide. Okay? So that's just a way to get back to the functions that you're expecting to get to. There's a couple shortcuts for casting. If you're getting a number, a string, an array, or a geometry, I think those are the four, then there's a get blah function that will short circuit and make you not have to do the casting. The reason that happens is this is not something that you can inline, right? It's not method chaining. There is no .cast function that will turn that on. You can't just keep casting. You have to actually wrap that around other things. And I hate that. And so these additional get functions let you do automatic casting along the way because it's a thing you have to do, and I want it to be easy. And the operator, right? Instead of doing slash, you do divide. And the math here is OK because these are literals, 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 literals. That math works out just fine when you run it right now, and the divide works out. OK? Good? Those are early errors. Those are the easy ones. It gets harder. There's a whole bunch of Earth Engine that is divided up into client versus server. And the client stuff is kind of easy and intuitive and not too hard, and we can help you guide it through it. And everything that happens on the server is essentially a big, giant black box. So I'm going to teach you a little bit on how to inspect into that. But more importantly, I'm going to teach you how to just avoid those problems in the first place. All right, so if we're mapping a function, now we're on the server. Everything's happening on the server. Mapping functions in Earth Engine is a weird thing. And I'm proud of how weird it is because we invented a cool thing. The way mapped functions work is that you pass in one of our proxy objects, one of our computed objects that doesn't exist yet, and it bounces around in that function, and things happen to it, and then you return a result. We do that when you call a map function and you click run. We do that for you. We make a fake object. We plug it into your function once. Things happen to it, and stuff comes out the other end. And everything that happened to it is recorded on that proxy object. And that's what gets coded up into your graph, into your description. So what that means is, essentially, your function is only ever going to get called once. And if you are, I'm going to skip around a little bit here. If you're doing something like branching in your function, that if is only ever going to have one value. Maybe it's true, maybe it's false, depending on how you built it. But you're never going to actually be able to test anything multiple times. That's not the way Earth Engine works. These are the ifs are like the pluses and the divides. They happen now. So they're imperative and they happen immediately. So when you do something like a conditional in your function, whatever this turns into, only this piece or this piece will ever happen. Everything that happens on the server will only use half of your function. The other half will just never even make it to the server because as our proxy object bounced around inside of that, the other half didn't happen. It didn't happen to the object. We don't know about it. OK? That's a little weird, I understand, but that's the way map functions work. We call it once, see what happened, encode that up in the graph, and that graph is what goes off to the server. So if you're expecting your mapped function to do something like export a bunch of images, not going to happen. It only runs once. If you're expecting it to add a bunch of layers to the map, not going to happen. It only runs once. So keep that in mind. Map functions only ever run once. Technically not true. They actually run about 3 times, but the why is unimportant. Just pretend it only ever runs once. All right, so things that can go wrong when you're mapping a function. Functions have to return a value. The way that the contract of mapped functions is they have one argument that gets replaced like an iteration. They have no side effects, so no exports, no maps, no prints, nothing that isn't happening directly to that variable. And they have to return a value. If you're mapping over an image collection, it needs, or if you're mapping over a collection, it needs to return an element. And that means either a feature or an image or another collection. Those are the subtypes for element. So here I've got a function, the top line, it fails because it doesn't return any value at all. So it will at least tell you mapped functions have to return a value. If you're in a collection, it will say must return a feature or an image, and it also means collection because you are mapping over a collection. Each row of the collection goes in, and the result goes back into a new collection. And you can't just stick a number into a collection. There is no collection of number or list or array or any of those things. Collections are only of images and features and other collections. Okay? So the result has to be one of those 3 things. A mapped function's arguments cannot be used in client-side operation. I think that's the right message that you get these days. But what that means is you tried to call something that has a side effect. You tried to call getInfo, you tried to call export, you tried to call print. You can't do that. Cut it out. I already talked a little bit about branching. You only get 1/2 of it. And then a thing that used to occur a lot, and if you try really hard, you can still make happen, is running too many reductions. If you map a function that does a reduction, you're probably OK. If you map a function that maps a function that does a reduction, you might then hit a limit on how many reductions you can have. There's other ways to hit this. But if you get an error about too many aggregations, that's what's going on. We have tried to fan out your computation. Typically, a map function runs about 20 things at a time. You're running 20 reduced regions at a time. But if you're mapping a function that maps a function, now you're trying to do 400 of them at the same time. And we don't let you do that because it's a shared service and you have to play nice. OK? You with me? Onward. Some things you shouldn't do. If your code has a for loop in it and you ask for help, too bad. I'm not going to help you. Don't use for loops. Now that said, I use for loops. Everybody uses for loops. Be very, very careful with your for loops. Don't do them except when you have to, right? Part of the reason is if you're looping over the contents of a collection, you're going to get info the collection, or you're going to get the size of the collection as a get info. Don't do that either. Don't use get info. But you're going to do it. When you say for I equals 1 to size of collection dot get info, the size of the collection might be 1 million or 1 billion or 1 trillion. You can have trillion element collections in Earth Engine. What's going to happen as your browser's trying to execute that for loop is that sooner or later your browser says, you really want to keep doing this? And it's going to try and crash. And you're going to lose your script. So for loops are pretty much a guaranteed way to crash your browser. That said, you want to loop over 4 maps to make a quad map, linked map or something. OK, you know that's not going to be 1 million. You'll be fine. But the other part of this is if you're looping over something that's got maybe 1,000 elements or something like that, every iteration of that loop makes your computed description, your computational description, bigger. And so a loop over 1,000 things doing something to your image, or this one I see a lot, I want to merge together a bunch of collections. And so I often do that, you guys often do that 1 element at a time. And so I make a new element and I merge it with a collection, and I make another element and I merge it with a collection. And I'm doing that in a for loop. What that's really doing is exponentially increasing the size of your computational description, and you will very rapidly run out of size of description limit. Run into the size of description limit. That's about 10 megabytes of description. It's very easy to hit that if you're looping 1,000 times over stuff. So generally, don't use for loops. Use map or iterate, except for those times when you really have to. All right, this is my favorite example ever. People remember this for long periods of time. When you call something like reduce region, you will often get a message, and it looks like an error that says too many pixels, max pixels is 10 million, you're trying to use 27 million, fix the, increase max pixels if this is really what you meant to do. This is what we call the blade guard. If you buy a table saw in America, it comes with this piece of plastic that lays over the top of the saw and keeps you from cutting your fingers with the saw blade. And if you're a normal American, you unscrew that thing and throw it away, and you run without the blade guard. Max pixels in reduced region is our blade guard. When you hit this message that says too many pixels, what's really happening is I'm telling you the thing you're about to run is going to be expensive. Maybe a couple cents, maybe a couple dollars, maybe a couple $1 million. Do you really want to do this? Yes or no? Tell me by increasing max pixels. If you're a non-commercial user, I'm paying for that, so I want you to be careful. If you're a commercial user, you're paying for that. I don't care if you're careful, but I think you want to be careful. Okay? So here's a real example where a guy came to one of my sessions and said, why doesn't this work? And I'm like, well, I see why it doesn't work. I'm not sure why you don't see it doesn't work. What he's done is he is trying to do reduced region in EPSG 4326. That's normal lat lon. It's 1 degree per pixel by default. And he says, I'm smart. I want to run at Landsat scale. I will use 0.00026 of a unit as that should mean 30 meters, right? No. The word scale, if you take nothing else away from this conference, The word scale in Earth Engine always means meters for this exact reason. It is never variable. It is never sometimes something and something else. It is always meters. And so this user is trying to run a reduced region with 26 micron pixels. And he did the thing that I tell everyone not to do. The max pixels error came up. It said max pixels is 10 million. You're trying to use 92 quadrillion pixels. What you should never do is copy that number out of the message and paste it into here, because first of all, it's not going to work because there's always some decimal fraction of a pixel here. And this user very carefully added 1 so that he'd fix that problem. But right, so heat death of the universe until this process finishes, and he was unhappy why it wasn't working. So don't copy that number in, except you will, and I will, and we all will. But it's on you that you've done that. What I do to avoid making this problem is that I just stop thinking. The intent here is to think. Please think about what you're doing when you get this message. 1e to the 9th is always safe. It's like it may take 10 seconds, 20 seconds, whatever. 1e to the 10th might take a little while. 1e to the 11th, go get lunch. 1e to the 12th, probably not going to finish. 1e to the 13th, you're just optimist. 1e to the 14th, give up, right? So just powers of 10 there. 1e to the 9th is safe enough that you probably are not going to spend much money. You're not going to spend a bunch of my money. If you're typing in 1e to the 13th and you've got problems, shame on you. That's a big number. It's going to take a long, long, long time for that to finish. And a lot of people just always do that. When they write reduced regions, they just always shove in max pixels 1e to the 13th. My favorite one is max pixels 1e to the 13th with a best effort. And what that means is we will go compute some scale in which your entire region fits into 1e to the 13th pixels. And so now you're doing a very expensive computation at some scale that you don't know what's happening. Maybe it's 26 microns. Maybe it's 100 meters. Maybe it's 1,000 meters. You don't know. So don't do that. No best effort unless you know why you want it. And the number for max pixels should be very small if you're doing best effort. OK, that was a fun aside. Don't do this. These aren't really bugs. They're just going to make your script slow. Please don't do it. Converting your collection to a list with a really big number and then trying to iterate over it. You can iterate on a collection directly. You didn't need to convert to the list. All you've done is sucked up a bunch of memory. If your collection really is 10,000 elements, instead of having a streaming collection, which is fast and efficient, you have turned it into a list that has to fit in memory, and you've just used up probably all of your memory, and you're going to hit an out-of-memory limit. Don't do that. Call iterate directly on the collection. Call map directly on the collection. If you're going to return a number, OK, now you've got an issue. Really, just put the number back into the feature, return the features. It all stays streaming. It all runs fast. It's all very memory efficient. I see this one a lot. And I actually asked my engineer in the back there that is a query optimizer guru, we'll go with that, query optimizer guru, to just make this go away. This person, or lots of you, take a collection, convert it to a list by taking the size of the collection first and then making a list that long. This makes sense until you then do something like this. I just want the first element. Just get the first element directly, right? Don't do that. But an important point, this thing up to get iterates through that collection twice. And that does take memory, and it certainly takes time. So we had to iterate through the entire collection to figure out how big it is. And if you're doing a big mapped albedo computation, reduction, blah, 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 this may take a minute. And then you're going to do it again to convert it into the list. So don't do conversions unless you really, really have to. And usually you don't have to. OK? Everything making sense so far? Are we having fun? Good. OK, the scary stuff, scaling issues. The things you will see most often are user memory limit exceeded. You run out of memory. I think the name on this has changed a little bit. It's an out-of-memory error. You'll see it. There's ways to fix that. They all require thinking. And I'll tell you about some of that in a minute. The other one that you get really frequently in interactive mode is computation timed out. Who's gotten one of those? If you haven't raised your hand, you're lying. OK, great. That one's harder to fix. Sometimes you can make your script more efficient. Often you can make your script more efficient. I want it to run interactively, you want it to run interactively, but sometimes the answer is you just got to run it as an export or export some intermediate piece. So you, instead of 5 minutes, you get 10 days. That's how long an export can actually run. Technically not true because we reboot the servers every week, and so really you're probably going to get about 4 days, but you're allowed 10 days. And that will make your really hard computation produce some intermediate result, and then you can run your interactive stuff on top of that. I'll tell you about a feature that we're about to launch. So I'm not supposed to do that, but I always do that, and how that plays into that in just a minute. Too many aggregations I mentioned. This doesn't happen very much anymore. Our backend engineers, I want to say got smarter, but we got new backend engineers, and they fixed things that we didn't ever bother to fix. So that one tends to go away. And then internal server error. I am fully aware that who's got an internal server error, right? If you haven't raised your hand, you're lying. This means the system did something we thought was impossible, or it's trying to do something that you couldn't possibly do anything about, like your authorization credentials have expired. We should really tell you your authorization credentials have expired, but what happens instead is we go, oh, we just get interrupted, and we say, I don't know what happened, but I don't have anything to tell you, and so it returns internal server error. Should you get an internal server error, I strongly recommend that you click on the feedback button right then. It will package up your script. It will send it to, honestly, me, and I will see what I can do about it. Because every time you get one of those, an angel dies. I don't know what, something bad happens, and we should fix it, right? We should get an alert. We often do get an alert, but that alert typically doesn't include your script. So if you can, let me have your script. Click the feedback button. It'll give me your script, and I can go reproduce it and make it not happen again. Okay, and that's just a constant battle of we make new code. It doesn't handle every edge case. You hit an edge case. Someone goes and fixes the edge case. Okay. Scaling issues. Computed value is too large. Again, you probably all hit this one. The way Earth Engine works is that things that are aggregations, things like reduce regions or training a classifier, those sorts of things, produce a table or something like a table, like a classifier, and that gets cached in our cache system. And that cache system can handle things up to 100 megabytes in size. It's a dumb number, but that's what we got. We never thought people would be making multi-gigabyte classifiers, and really 100,000 rows is enough for anybody, right? But people come and they show up with 1.7 million points that they want to sample and put into a table and have a feature vector that's 1,000 elements long, and that whole thing is way bigger than 100 megabytes. And really, your only hope when you get computed value too large is to cut the thing you're working on into pieces. If you're sampling 1 million points, don't sample 1 million points all at once. Sample 100,000 points 10 times. A, it will get you more parallelization, and B, any one of those single pieces will now fit in the cache for some value of 10,000 and 100,000. And then you can combine them at the end and put them in. So computed value too large, your only hope is to break it up into smaller pieces. Or if this happens to be the classifier, if you're training a classifier and the classifier doesn't fit in cache, you got to make your classifier smaller. And the way to do that is, for something like a random forest, use less trees, or there's a min leaf population. Don't let it make any leaves smaller than 2, that use less than 2 elements out of the collection. Make it smaller. That's your hope. Feature has non-numeric property. When you sample using the sampling methods in Earth Engine, any point, okay, so let's say we're sampling Landsat, right? We've got a whole bunch of points, we're sampling some Landsat values. It goes and gets all the bands at the point, and it tries to make a feature out of that. If any of those bands have a null in them, the thing is thrown away. Our thinking was the sampling functions are designed and intended to be the thing that happens right before you classify. And classifiers can't take null values. So if you've got a null value, rather than making you filter them out, we filter them out. But if you're hitting an image in which, for instance, the thermal band was turned off, and there's a whole section of time in 2021 when that happened, you sample that image, every single pixel has an empty band 10. Every single pixel gets thrown away. Every feature has a non-numeric value or a null value for some particular band. In this case, it's say band 10. You got no training data. There's another message for no training data, but it's the same thing here, where a bunch of your features were thrown away, or some of your features made it through with a property that's either null or non-numeric. OK, so those are two of the big ones all around classification. The other one that you'll often hit is that your task will have timed out. You're like, OK, it was too big. It took too much time. I will run it as an export. Noel says I can get 10 days on my export. Really, it's 4 days, but OK. But often, your task will say timed out after 7,200 seconds. What's happening here is that the whole task has a 10-day limit, but any one row of a table or any one tile has a much smaller limit. And we just want to make sure that your computation is progressing so that you're not consuming an infinite amount of resources. If we gave every single tile up to 10 days, you could easily make a crazy long computation. So you'll see something like task timed out after 7,200 seconds because one feature was taking too long to compute. And sometimes that one feature was, in fact, your entire computation. Right? You do some great big crazy computation and you shove it into one feature and then you try and export that feature. You don't really get 10 days on that one feature. You get 7,200 seconds. And there's a number of these things. There's a whole page on limits in the system that will tell you what those numbers are. OK? Not real helpful yet. The helpfulness starts soon. Right, OK, so I mentioned this in my machine learning talk. If you have, let's say, a reasonable number, let's say 250,000 points that you're trying to sample for the continental United States, a reasonable way to do that is to try to do a reduce regions with your 250,000 points, and you turn it on, and you let it go, and maybe you're going to export the result. If that result is more than 100 megabytes, or takes longer than 5 minutes, ignoring the export part, it's too big, right? It can't finish. And so what we used to tell you, I'm going to tell you something different. What we used to tell you is, OK, stop doing it all in one go, map over the collection, and run a reduce region at each point. And what this does is it puts each point into the cache basically as its own table. So instead of one table of 250,000 points, you have 250,000 tables of 1 point. This works. It avoids all your out-of-memory issues. It avoids your timeout issues. The tables all fit in cache. This is intentionally the opposite end of the spectrum for all of the limits. But here's the catch. Around 250,000 points, when you go to use this table, we have to get all those values back out of the cache and reassemble that table, like to go into a classifier. We can only read 100 cache values a second. And at, I think it's 300,000 points, basically, reading that table out of the cache takes longer than the 5 minutes you've got for an interactive operation. The whole punchline here is export avoids most of this. So you can export your table and skip around this. But it's much better to use the largest chunk you can where you don't hit the limits. Right? And you're only going to hit this when you're up in a very large number of points. When you're on the edge of the system, you'll have to do your own cutting things up. I apologize. This is, you're exceeding what we expected Earth Engine to have to do. But I demonstrated in my talk on Monday, cut your region up into 10 pieces, run a filterBounds on each of those pieces, map a full reduced regions over each piece. That will give you 10 tables, each of which runs 10 times faster. And at the end, you can either combine them all back or export them into multiple files, whatever. It's a smaller unit to work with, not 250,000 units, 10 units, easier to work with. Okay? Shouldn't have to do it, but we do. OK, here's the fun part. If you've gone to office hours this week, you might have encountered something like this. These are all the places in the system that are sticky, where you're most likely to hit a problem. I'm going to walk through them. I'm going to try to explain a little bit about each one. But really the point here is when you go home and you've got a scaling problem, a limitation that you can't overcome, like this thing just isn't going to work, you can work through this and more importantly just avoid these things to begin with and try to do the debugging on your own. All right, so the lowest hanging fruit, don't use getInfo. There's very few places you need it unless you're building a UI. Sufi's going to work on that. He complained about it this week himself. So trying to get things out of the server back into your client is bad for your client. It takes time for the results to happen. It's very non-scaling. Don't do this if you can avoid it. For loops. I've already shaken my finger at you about for loops. Avoid them. Iterate is what you would use if you really need a for loop and you can't use map. You would reach for the iterate function in Earth Engine to do that. Unfortunately, it's got part of the same problem as for loops. The iterate function, when it all gets to the server, we actually unwrap that iteration. And you can end up using up too much memory. There's a lot of memory there to use, but it is possible to run out of memory just because you had a great big iterate. Always, always, always try to use map if you can, because it will stream an infinite amount of data, whereas iterate definitely has a bounded limit. If you're doing something really complex in your iterate, that means every unwrap of the iterate function becomes a really big piece of memory. Avoid it if you can. Don't ever call toList, except we all do, and you'll sometimes need to. But avoid conversions. This just sucks up memory most of the time. If you've got a really complex geometry, this is where most people have trouble. If you take one of the data sets that has country boundaries in it out of Earth Engine, and you say, OK, I want to use the North America. I want to use the boundary for continental United States, but you use the state boundaries and you just put them all together. That's a really, really complex boundary. It's on the order of a couple million points, and every time you use that geometry, we have to reproject it into the output projection, and that can take a lot of memory, but more importantly, a lot of time. So often, all you just want is all the continental United States. If you can draw a box, that's way better. It's just 4 points. The projection happens really fast. Maybe you do a little extra computation on the edges, but maybe that's not a problem. So try to minimize your complex geometries. My favorite one, and I say this it's not my favorite one. My least favorite one is I want to do the whole world. So I just grab the Gaul boundaries and I run some NDVI extraction for every Gaul boundary. There are no trees in Antarctica. Do not run an NDVI tree extraction in Antarctica because it's a gigantic geometry. Most people, when they're trying to do some kind of world aggregation, they include Antarctica. They don't even need it. And it takes 90% of their time, and everything else just takes that other 10%. So clip out Antarctica if you don't need it. And even better, simplify your geometries. Use simple geometries where you can. There are simplified versions of many of our geometry tables. Even those can be really big if you're not careful. Trying to use all of the United States by county and just merging all the counties together, you're again in a couple million points, and the reprojection could take a very long time. Don't clip. I know this seems counterintuitive, but it often takes longer to reproject the geometry to do the clipping than it does to do the computation that you're trying to avoid by clipping. If you're going to clip, if you don't want, you're working in Colombia and you don't want to see Nicaragua, okay, great. There's a clipping that can happen, but do it last. Do it as the very last step of your process. Points that you didn't need won't get computed, and we don't have to recompute that geometry over and over and over to do the clipping, especially if it's one of these complex geometries. I think it might be on the next page, but I will mention it right now. If you've got an entire collection of a gazillion points or a gazillion boundaries or whatever, and you try to use that as a geometry, one, it may often not be what you want because we do symmetric intersection inside of that as we flatten it into one geometry. But two, it is again, perhaps a million points that all have to get reprojected at the same time. So complex geometries are a problem. Avoid them anytime you can. If you can just get a bounds, that's great. If you can draw a box, that's even better. It doesn't, waiting an hour for your geometry to reproject just because you didn't want to draw the box. Draw the box. reduceToVectors. OK, so there's a function, reduceToVectors. It's designed to convert images into geometries. And sometimes it's the right tool, especially if you want to do something like compute the area of a bunch of forest patches. That's exactly the tool you should be reaching for. It will scale to very large areas. But do you really need the geometries? Because it can produce individual geometries. It traces out every single pixel. So one pixel can actually be 4 points in your output geometry. A lot of pixels can be a million, a billion points in your geometry. You're going to have a hard time with that. The whole point of reduceToVectors is not just the vectors part, but the reduce part. If you just want the area of a whole bunch of forest patches, reduce an area image and just use the centroid. The output will just contain the centroid telling you sort of which patch it was, but all the pixels will get summed up right then and there. I see a lot of people run reduceToVectors, make a bunch of vectors, and then call area on every single vector, or call reduce on every single vector. You're making your life hard. You're spinning a lot of computers. You're dimming the lights in Dublin. Avoid this whenever possible. Use the reduce part and decide, do you really want those geometries at the end? Or can you maybe combine a couple reducers and never need to actually see or touch the geometry? It will run much faster and not run out of memory. I like to say don't use reproject, but there are times when you just gotta. But 99% of the time, you didn't need to reproject. Earth Engine is essentially a giant reprojection system. It does resampling for you automatically. Unless you're trying to do something funky, like count the number of Landsat pixels inside of each MODIS pixel, or there's a few new cases where you have to, if you want the slope of a combined DEM that has no projection, you have to give it a projection. There are a couple places where you need to reproject, but unless you are certain that you needed a reproject, I'm certain you didn't. So don't do that if you can avoid it. Same for resample. You probably didn't really need to resample that image. It's probably just adding extra time. Maybe you did really need to do it, but probably not. So just be careful on those two. Reduce resolution. Again, Earth Engine knows how to downsample things. The only time you need reduced resolution is when you are intentionally trying to do something other than what the system does by default. If you want to take the maximum of every Landsat pixel inside of each MODIS pixel, that's where reduced resolution comes in place. It's not just, I want to convert from 30 meters to 1,000 meters. So the system does that automatically. This is for very precision, special kinds of computations for small, smaller pixels to larger pixels. Joins. Joins are fun. We have a join system built into Earth Engine. You've got 2 tables, you want to join them, or 10 tables, you want to join them. You can make that work. Sometimes it will have a problem. The opposite of joins is doing a mapped filter. So if you want to join 2 collections on their system index, there's a function, joins will let you do that. Alternately, you could map over the first collection, and for each element, filter the second collection to a matching system index, or something like that. Filter to an intersection of geometries. I don't have a hard, fast rule here, but if you've got a bunch of joins in your system and it's not working, basically just convert them all over to the other one, and vice versa. If you've got a bunch of mapped filters, maybe a join will be more efficient. It's enough of a black box, I don't even have an answer, but often the other answer is the one you want, depending on what you're doing. OK, collections. Always filter as much as you can. Filter by date and filter by bounds first. Those are filters that are supported by indexes. They are super fast. They're essentially 0 cost. Other filters, things like calendar range, where you're filtering by day of year, that is not supported by an index. And it will be very expensive because all the data has to be brought over. Then we figure out which ones it is, and then we throw away a bunch of them. Whereas the other ones we can avoid, maybe 99% of the operations just because they've filtered out. So use filterDate and filterBounds first as often as you can. Before you map, just put them at the top. And you'll see on my examples, that's always EE.ImageCollection, filterDate. That's just always, they go together. If you're doing a calendar range of, I fixed this one after last year. People used to do calendar ranges of year. And like I said, calendar range is not backed by an index. But you could have just done a filterDate by 1/1/2016 to 1/1/2018. That would get you a very fast index. Filter by calendar range by year of 2016 to 2018 does the same thing, but costs 1,000 times more. So avoid that if you can. Calendar range is a thing you often need. Do it last, and make sure there was a filterDate in front of it. Don't take the geometries of big collections. I already talked about that one. You can end up with a really, really complex geometry. Again, sometimes you need to, but make sure that's what you really wanted to do. Yeah, okay, and then two bands. Many of you probably have taken a big collection of Modis or something like that, and you're like, I've got 7,000 images or 700 images, and really what I want is a 7,000 band image. And so you call two bands. It'll work, but now you've got a 7,000 band image, and that can be a problem. So if you've got a big collection converted to two bands or two array, you may have some issues, and you may need to break it up. When you're doing aggregations and you run out of memory, the answer is always tile scale, add a tile scale. That also is true for collection. I can't read that. Okay, thank you. This is also true for collection reductions. So if you are doing a median composite, there's a tile scale option. You may want to use it there. Combine your reducers anytime you can. This is usually the biggest savings you can have. If you run a reduce regions with a max and another reduce regions with a min, we have to fetch every tile twice. And sometimes you've got 10 or 12 of these that you want. Combine all of those. We'll just get tiles once. You'll thank me. If you're using reduceNeighborhood, specify a reasonable neighborhood size. If you really only need 5 pixels, just use a 5 pixel neighborhood size, don't set it up to 50. And there's a couple optimizations on reduceNeighborhood which will make it go faster. So should you be in the neighborhood reduction business, make sure you read up on the docs on reduceNeighborhood because you can make it much, much, much faster. Along that lines, you can actually usually do fastDistanceTransform instead of reduceNeighborhood or focal min or focal max or any of the focal operations. Lots of people use this for erosion and dilation. Like if you're trying to do erosion and dilation, use fastDistanceTransform instead. It's orders of magnitude faster. I spent an entire 6 months on making this work. It's a super cool algorithm. I really want you to use it, but also it is ON. It's linear in size, not squared in size. These are straightforward. If you've got geometry, specify an error margin. Simplify them if you can. Do bounds or draw a box if you can. Or just get rid of the geometries completely, like in the case of reduceToVectors. Pre-cache by exporting an image before you sample. Limit the size of your classifier. And never, ever, ever, ever use math.random in your script because it breaks all of our caching. Every time you click run, we will have to rerun everything from scratch, which maybe is what you wanted, but it probably isn't. It will make everything slower for you. Don't use this as a seed in your functions. You'll be sad. This is 1 minute's worth of stuff. We have a profiler. Turning on the profiler gives you some information about what's going on. It's approximate. It gives you a little bit of indication about what's going on. Don't be super into relying on it. It's the best we could do in a crazy distributed system like Earth Engine. But it does tell you some stuff like clamp is where all your time is going. OK, finally, to get help, we have a users group. We have a users guide. The good news is it's 400 pages. The bad news is it's 400 pages. It's hard to find stuff in it. If you can't find what you want in the users guide by doing a search, you go to the users group. To get help in the users group, create a meaningful tile. Tell us what you're really trying to do. I'm mapping rice paddies in Montana. Is that a thing? I don't know. But it's important that that will tell. Like, well, just say, there are no rice paddies in Montana. Cut it out. Reduce your problem to the smallest unit because that's the easiest way to get help. Throw away the irrelevant code. Even big blocks of comments, we still have to go through those. Always, always, always add a script link so I can run it and see what the problem is. And any assets you're using, make sure they're public and available. There's 27,000 users on our users group, and many of them are very helpful professionals that really want to help. So This is a great resource, but try to use it wisely so that you can get the answer as fast as possible. In many cases, you can get an answer in 3 to 5 minutes. Who's gotten a 3 to 5 minute answer from me? Yeah, OK, so I'm not lying. Do that. All right, that's my talk. If you've got questions, there's a mic. If you've got hard questions, I've got office hours today. Thanks for coming. Any questions? Yeah, in the back. Mike, please.
Thank you so much. Super useful, and now I know that I have to avoid so many things.
Yay!
Yeah. So I have a question about pixel area, because when you compute the pixel area, you can actually get different results sometimes. So I don't get a message of error, so I am not sure if I am getting the right number or not. But if I compare the geometries in QGIS, I get a different number. So what is the reason for that?
The answer is almost certainly weighted reducers. Are you weighting by the pixel size or not? You draw a geometry at a diagonal. It cuts through a bunch of pixels. Do we include the pixel or do we not include the pixel? Does QGIS include the pixel or not include the pixel? How much of the pixel? It's all about weighting. The answer usually goes away if you unweight everything. You'll get matching answers, but that's not what you want. So I think we try really hard to make that one as accurate as possible. I think we're right, but I can't guarantee that. So it's weighted reducers. Yep, right there. We're over, so if you want to leave, you're not going to offend me.
Thanks. You said a couple times for the computation timed out to break up your collection into pieces so that you can try and run multiple parts at the same time. Do you have any advice on how to optimize the selection of how big those chunks should be so you're not making too big of chunks or too many tiny chunks?
No, try it, but locality matters. So for instance, if you've got pixels all over Europe, chunking them up by location means that any 2 pixels might share a tile, and we don't have to fetch it again. So chunk by locality as much as you can. In terms of size, no, it's totally, there's so many variables in that equation. How deep's your feature vector, how deep's your stack, are you using doubles or shorts? There's just too much to try to guess. Use the biggest thing you can, let it fail. You won't get charged for the failure, and work your way back down till it works. All right, I'll see you guys at office hours if you have any harder questions. Thanks for coming. Oh, wait, one more. Yeah.
Okay, sorry. Thanks.
Sure.
Thanks for your presentation. You said that the reduce resolution function is not for like 10 meter to 30 meter switching, which is exactly what I thought it was for. So could you talk a little bit more about how you said GE does this anyways? Could you talk more about that and how that works?
Yes. If you try to do something at 3,000 meters on a 30-meter image, well, let me even back up. When we load data in, we pyramid it. We downsample it by powers of 2. Anytime you're trying to use an image other than its native resolution, we find the resolution closest but higher. So you've got perhaps mean sampling to that point, and then we use nearest neighbor after that. And so if you're going from 30 meters to 3,000 meters, we will try to use the 60, 120, 240, 480, I don't know, whatever it is, it's 2460 level image that was downsampled from 30 meters, and then nearest neighbor sample on that, which is probably what you want most of the time. If you really want exactly 3,000 meters, and it's not one of the powers of 2, then you can use reduced resolution for that. But even then, that might not be what you want. Different projections and whatnot, you might not be able to get exactly a 10,000 or a 1,000 meter pixel. I just answered a question on the forum last week. Somebody thought that they were able to aggregate 2 by 2 pixels from Landsat into MODIS. And I'm like, well, that isn't going to work, right? There are different projections. You're never going to get exactly 2 by 2. So most of the time, we believe that the downsampling that Earth Engine does is probably what you want. If you think otherwise, ask or try it and see. The worst that happens is you use a lot more compute and memory than you expected.
Thank you.
Thanks.
you.